Hello ladies and gentlemen, my name is Kevin and I want to teach you how to create your own network with a dedicated server using Unity3D and C#. This tutorial series will have 5 parts in total, covering up following topics. Part 1. Creating a byte buffer class. Part 2. Creating your own server connection. Part 3. Connecting your Unity3D client with the server. Part 4. Sending data between server and client. And Part 5. Instantiate player over the network. But before we start, I want to mention that I have our own homepage called kevinkaimak.com. There you will be able to ask any questions you want related to game development. Also, you can check out my Discord channel, and if you do like this video and want to support me as well, you can visit my Patreon page, which allows me to create YouTube tutorials like this. All links you can find below this video in the description box. Without further ado, let's get right into the first part. Before we start coding, I want to explain you what a byte buffer class is and why we need it. A byte buffer class let us create very simple a so-called packet, which then we can send over the client to the server or from the server to the client through the network. This class is able to convert different variables into a byte, which then is added to a list. The list will get then converted into a byte array, which then is a called packet, which then is ready to get sent over the network. The receiver of this package will be able to read all the data out of it. And we are able to send following variables. We are able to send a string, an integer, a long, a byte array, a short and a float. Because we do want to implement this class into our server and client project, we are going to create a DLL file out of it because we don't want to recode everything over and over again. That's why we are creating our own DLL file using the byte buffer class. To do that, I am using Visual Studio and I'm going to create a new DLL project. I'm going to File, New Project, and then I'm using Visual C# and I'm going to use the class library.NET framework. To implement it into Unity, we have to use the Net Framework target 3.5, else we won't be able to implement it into Unity. I will give it the name, let's say, byte buffer. That is a great name. Alright. Once we have created this byte buffer project, we can start coding right away. Before we do that, we are going to delete the namespace. And also we are adding a few directives right on top. We are going to use using system.collections.generic. As next we are using system, and also we do need system.text. Then we can rename our class directly. We are going to rename the class, let's say, byte buffer. We are going to rename the class there right as well. Byte buffer. There you go. Okay, to start off, we do need to create a few variables. First of all, as I already said, we are going to add everything to a list. Therefore, we are going to create a list first. So we are going to create a private list, and the list will be a byte list, and we call this list buff, short for buffer. As next, we do need a byte array, and we call this byte array private byte array read buff. As next, we are going to create an integer, private int, and we call this read pos. As next, we do need a bool, and therefore we are creating a private bool and call this bool buff updated equals to false. As next, we are going to create our first method. So every time we are going to create a new packet, we want to create a new instance of this class. So therefore we are going to say public byte buffer, and then we are adding into it buff is equal to new list. As next, our position will be readPos equals 0. As next, we are going to create a getReadPosition function so we know at which position we are at when we're reading out the packet list. So therefore we are going to create a public long and we call it getReadPos. And we are returning our readPos. As next, of course, we want to convert our list into a byte array to send it over the network. So therefore we are going to create a public byte array and we call this simple toArray. So we know what this function does basically. And what do we return? We return our buff.toArray. As next, we want to count how many information is stored in our list. Therefore, we are going to create a public int, call it count, and then we return our buff.count. Let me resize the text for you a little bit so you can see it. Go. As next, of course, we want to know the length of our list. So therefore, we are going to create a public int. We call it length. And we are going to return our count minus our read position. So we know which is left to read out. And last but not least, we want to clear our list. So therefore, we are going to create our public void. We call it clear. And then we say buff.clear and our read position is 0. Awesome. Now we have created a few functions which makes us the life a little bit easier. So let me minimize it. There you go. As next, we want to write information into our list. So therefore we need to create a few functions to convert our string, for example, into a byte and add it into our list. So therefore we are going to create at first our public void write bytes in example, and we have a parameter of byte array and we call it input. Okay, to add something into our list, we are calling our list, in this example buff.addRange, and then our input. And then we are calling our buff updated equals to true, because then we know, okay, we have added something into our list, therefore we are going into the next line. As next, we are creating our function, our method for our short. So we are going to say public void write short. We do need a parameter of short and we call it as well input. And then we have to convert it into a byte. And how we do that is we calling our list again, buff.addRange. But then instead of using our raw input of short, we are going to use our bit converter .get bytes, and then our value will be our input. And then we say buff updated equals true. As next, we want to write an integer into our packet, into our list. So therefore we are going to create a public void write int, or let's say write integer, and our parameter is an int called input, and as well we are going to say buff.addRange. Again, we have to convert it into a byte. We are going to use bit converter .get bytes and then our input. And again, we are saying buff updated equals to true. As next, we want to write information about floats. So again, we are saying public void write float. We do need a parameter of float, and we call it again input. And we say buff.addRange bit converter .get bytes and input. And then buff updated equals to true. And now we want to write our long to our information list. So again, we are saying public void write long. We do need a parameter of long input. And then we say buff.addRange bit converter .get bytes input. And again, buff updated equals to true. Now the complicated part. We want to add string to our list as a byte. So that's why we are going to create a public void byte string. We do need a parameter of string called input. But now we do need to convert our string, okay, into a byte. And also we need to add another information of the string length. So therefore we are going to say buff.addRange. First of all, we are converting the string into a byte. We are saying bit converter .get bytes. This time our input .length. And as next, we are going to create or we are adding the string itself. So we are saying buff.addRange encoding, not encoder, we want encoding .ascii or ASCII .get bytes by input. And then we say again buff updated equals to true. Awesome. Now we are able to write any information we want into our list and then convert it to a byte array to make it ready to get sent over the network. So let me minimize all of this class, all of these methods. But now we don't want only to send the information over the network, we want to read this package also out. So therefore we are going to create the opposite. Instead of writing the data into the list, we want to read out the list. Therefore we are going to create first our read integer. Or let's start with write bytes. We are going to create a public byte array, and we call this read bytes. Instead of write bytes, we are calling it read bytes. And we do need an int of length and a bool of peak, which is always to true. Okay, I see already we do need our integer to read out our bytes. So therefore we are going to create first our read integer. So I'm going to add a public int and call it read integer. And the only thing we need is our bool peak equals to true. Alright, so we are creating a if statement first. So if our list, in this case buff.count, is greater than our read position is currently at, where we read out the list, and then we are checking if the list is updated. So we say if buff updated. So when the list is updated, we can say read buff is equal buff to array. And then we are saying buff updated equals to false. But if we don't update, so if we are not writing anything to our list, we are going to read it out, which means int, we say ret equals bit converter. We are converting the byte back to an int, and therefore we're saying to int 32. Our value will be our read buff, and our position, our index, will be our read position. And then we can say if peak and buff.count, buff.count is greater than read position, then we are moving to the next list. In this case, an integer is a value of a 4, so we are saying read pos plus equal 4. And then we are returning our ret. And that's how we are going to read out an integer from our byte list. But then we do need an else. So else something is there's an error. Then we can say throw new exception, and we can say byte buffer is past limit. Awesome. Now we are able to write integers and read out integers. Now we are moving on with our byte array. So it is always the same method. So we can basically copy and paste over, let's say only this part. So we are copying it over. So now we can say if buff updated, read buff equals buff to array, buff updated equals to false. That is correct. But instead of int ret, we are going to say byte array ret is equal, instead of converting it, we are going to say buff dot get range, our read position, our length, and then dot to array. And then we can say if peak, we can delete the rest of it. So if peak, then we are going to say read pos plus equals the length of our byte array to read out the next information. And that's it. That's how you reconvert your byte array from a byte. Awesome. Minimize that, and we can minimize that. As next, we want to convert back our string from the byte. So therefore we are going to say public string read string, and we do need a bool called peak equals to true always. And now we can again just copy and paste everything over, and now we just have to adjust it. So of course, as you know, we are writing the length of the string into our list, so therefore we do need to read out the length of the string first. So therefore we are going to say int length, short for length, equals read integer, and then we say bool to true, because we are reading out the information from the list, and move on to the next step. Then we can say if buff updated read buff equals buffer to array, buff updated equals to false, and then we are renaming our int ret to our string ret. And now instead of a bit converter, we again using encoding dot ascii or ASCII dot get string, and then we do need our read buff, we do need our read position, and we do need the length of the string, which will be our len, which we just have created. And then we can say if peak and buff.count is greater than read position, then we can say if ret.length is greater than 0, then we are going to say, let me in right here. Then we can say read position plus equals our string length to read out the next information of our list. Awesome, and then we are going to return our ret. So, as next, we are going to read out our short. So therefore, we are going to create a public short and we call it read short. And again, we do need our bool peak equals to true. All right, so again, we can just paste it in, paste in our information we just have created. So if buff updated, no, we do need another if statement. We can basically, since short is mostly the same like integer, we can copy and paste everything of that. We can paste it into our read short, and instead of int ret, we are going to create a short ret, bit converter to int32. A short is a 16-bit, so that's why we are going to say to int16. Our read buff, our read position. Okay, then if peak and buff count is greater than read pos, and of course a 32-bit int is always equal to 4, but a short, which means is an int of 16, is the half side, so instead of +4 we are saying +2. Awesome, and that's it for the short. As next, we want to read out our float. So again, we are going to say public float this time, read float, and then again our bool peak equals to true. And again, we just passed in our code from before, and instead of int again, we are using float ret, bit converter. Instead of to int32, a float is a decimal, so we do need a parameter of single. So we say bit converter to single, our read buff and read position, and then we can remain everything like that. A float is a 32-bit value, so the +4 is okay. Awesome. And last but not least, we have to create our method for reading out our long, which is a 64-bit value. So we are going to say public float, no, not public float, public long, read long. And again, we are going to use our bool peak equals to true. Awesome. And then we just passed in again our code from before. But instead of int ret again, we are using long ret, bit converter. Instead of to int32, we are going to use to int64. And instead of using read pos plus equals 4, again it's a 64 int. We are going to use the double of it, so we are using plus equals 8. And then we return our ret. And that's it. Last but not least, we have to create our iDisposable class method. For that, we are going on top of our byte buffer class. We hit the double point, and we are going to say iDisposable, which you can see right here. And on the very bottom of our class, we are going to create our iDisposable, which basically clears the buffer and deletes it from the instance. So we are going to create a protected virtual void, and we call this dispose. And of course, we want to have a bool which is called disposing. Okay, before that, we are going to create a private bool, and we call this disposed value, which is equal to false. It is there for or to detect. Let's to detect when to then calls. There you go. Okay, so in this method we are going to create an if statement. So if not dispose value, okay, if not dispose value, then we are saying if disposing. So if we are going to dispose it, if disposing, then we are going to clear our buffer. So we are saying buff.clear. And as next, our read position is pos, read pos equals to 0, because we are clearing the buffer. And then we can say dispose value true. As next, we are going to create a method where we are going to remove, or where we are going to dispose our instance of our byte buffer. So we are going to say public void dispose, and then we can say dispose true, and then we can say gc dot suppress finalize, and then this instance. Awesome. That's it. Now we have successfully created our DLL file with all its values, and we are able to create it. So we are going to right click on our byte buffer in our Solution Explorer, and then we are going to start we are going to build it, excuse me. So we are going to build it. The byte buffer build has started. As you can see, our build was successful, and now we are open our file explorer. And as you can see in our bin debug folder, you can see our byte buffer DLL, which we then can implement in our Unity client or server project. That's it for the tutorial. We are going to implement it in the next video into our server, and then we are going to use it right away. I hope you guys did enjoy this video, and if so, you can leave a thumbs up, you can leave a comment, you can even subscribe to my channel. Thank you for watching, guys, and see you in the next part.